Hello students, welcome to my YouTube channel MJ Classes. Here we are discussing about the oxidation number or oxidation state. Oxidation number denotes the oxidation state of an element in a compound as certain according to a set of rules formulated on the basis that electron pair in a covalent bond belongs entirely to more electronegative element. The statement means that there are the set of rules which are on the basis that electron pair in a covalent bond always belongs entirely to more electronegative element, and from which we can calculate the oxidation number or oxidation state. In simple language, we can say it is an imaginary number or charge that appears on an atom when all the bonds in a molecule are assumed to be 100% ionic. So to understand the oxidation number, we have to know about how we can break a covalent bond. So we take an example, a molecule AB bonded with covalent bond having electron pair between them. Now if we assume B is more electronegative than A, and these electrons will shift towards B, and A will be A positive and B will be B negative. So that is the simple way how we can break a bond, a covalent bond. Okay, next let me take an example of AA molecule. Two electrons are between them. When we cleave it, two radicals will be formed, A radical and A radical. These are the two radicals which are formed. Next, when we see how we can break a coordinated bond. To break the coordinate bond, let us take an example A, B. Here A, B are bonded by coordinate bond, that is the sign of coordinate bond. Now there are the two electrons between them, and we assume that B is more electronegative than A. If B is more electronegative, then these pairs will shift towards B, and B will become 2 negative and A will become 2 positive. Okay, so by this method we can break a coordinate bond. Now let us assume the opposite case, that here in this case A is more electronegative than B. If A is more electronegative than B, then what will happen? These electron pairs will shift towards A, and A will become A0. A have no charge and B have also no charge. Why? Because A will get its own electrons, because before the bonding with B, A has already these two electrons. It gives the electron, or it shares with the electron with B and form the coordinate bond. So when we break the coordinate bond, these two electrons will shift towards A, and A will become neutral and B will also become neutral, because neither A gain electron nor B gain the electrons. Okay, next we see the example CO2, carbon dioxide. When we see the carbon dioxide molecule, C double bond O, double bond O, double bond O. Okay, we will break it. So we have the carbon molecule, carbon dioxide molecule. We will break it. Carbon have the +2 charge, oxygen have the -2 charge, carbon have the +2 charge, oxygen have the -2 charge. Overall, when we see carbon have the +4 oxidation state and oxygen have the -2 oxidation state. So we can say that in the carbon dioxide molecule, carbon have +4 oxidation state, carbon have the +4 oxidation state, and oxygen have the -2 oxidation state. Okay, next when we talk about the carbon tetrachloride, in carbon tetrachloride, you will cleave these bonds and see that plus 1 charge here, minus 1 charge here, plus 1 charge here, minus 1 charge here, plus 1 charge here, minus 1 charge here, plus 1 charge, sorry, yes, plus 1 charge here, minus 1 charge here, and the overall charge carbon gained is plus 4 and chlorine minus 1. So from here we can say carbon have carbon have plus 4 oxidation state and chlorine have plus minus 1 oxidation state. Next, for H2 we break the OH bonds, minus 1 charge oxygen, plus 1 charge hydrogen, plus 1 charge hydrogen, minus 1 charge oxygen, and overall when we see oxygen have minus 2 charge. So from that we can say in water molecule oxygen have minus 2 charge and hydrogen have plus 1 charge, or oxidation state. Oxygen is in minus 2 oxidation state and hydrogen is in plus 1 oxidation state. Now we will talk about the ammonia molecule. In ammonia molecule we will break NH bonds in ammonia. You will get minus 1 charge, minus 1 charge, here also minus 1 charge, here plus 1 charge, here also plus 1 charge, here also plus 1 charge, and overall when we see nitrogen have minus 3 charge and ammonia have, from that we can say in ammonia nitrogen have plus minus 3 charge or oxidation state and hydrogen have plus 1 oxidation state. Now we will talk about the carbonate ion. In carbonate ion we have carbon double bonded with O, single bond O negative, single bond O negative, and when we cleave it carbon plus 1, oxygen minus 1, oxygen minus 2, carbon plus 2, oxygen minus 1, okay, and carbon plus 1. And when we see the overall charge on carbon, it is plus 4 and oxygen have minus 2. So from there we can say in carbonate ion carbon have plus 4 oxidation state, oxygen have minus 2 oxidation state. Next we will talk about the chlorate ion. In chlorate ion same, so we see here overall chlorine get plus 7 oxidation state and oxygen get minus 2 oxidation state. So we can say that in chlorate ion chlorine have plus 7 oxidation state and oxygen has minus 2 oxidation state. Next, one more method for calculating oxidation state is XA plus YB equals to Z. Here we assume a molecule AXBY, Z a molecule, X is the number of A and Y is the number of B atoms. A denotes the oxidation state of A atom and B denotes the oxidation state of B atom, and Z is the charge on the molecule, and overall formula is this. Okay, We will apply this formula in the fewer examples ahead. First example is sulfuric acid H2SO4. Here we have to calculate the oxidation state of sulfur. The number of hydrogen is 2, oxidation state of hydrogen is +1, the number of sulfur is 1. Oxidation state of sulfur we don't know. The number of oxygen is 4, oxidation state of oxygen is -2, and overall charge is 0. So the oxygen state we have evaluated of S is 6. So the simple method from which we can easily calculate the oxidation state of sulfur or any atom in any molecule. Okay, next H2SO3, that is sulfurous acid. In the sulfurous acid we have to calculate the oxidation state of sulfur. So number of hydrogen is 2, oxidation state is +1, number of sulfur is 1, and oxidation state of sulfur we don't know, and the number of oxygen is 3, oxidation state of oxygen is -2, and total charge or overall charge is 0. Then sulfur has oxidation state 4. Sulfur has the oxidation state 4. Okay, next we will talk about the nitric acid. In nitric acid we have to calculate the oxidation state of nitrogen. Okay, so number of hydrogen is 1, oxidation state of hydrogen is +1, number of nitrogen is 1, oxidation state of nitrogen we don't know, number of oxygen is 3, oxidation state of oxygen is -2, and overall charge on molecule is 0. So nitrogen have the oxidation state +5. Okay, easy. Next example is H2H2O8. It is also known as the Marshall's acid. Okay, here we have to find out the oxidation state of sulfur. Number of hydrogen is 2, oxidation state of hydrogen is +1, number of sulfur is 2, oxidation state of sulfur is we don't know, and number of oxygen is 8, oxidation state of oxygen is -2, and overall charge on molecule is 0. So the oxidation state of sulfur is +7. Okay, next H3PO5. Here we have to find out the oxidation state of phosphorus. Number of hydrogen is 3, oxidation state of hydrogen is +1, number of phosphorus is 1, oxidation state of phosphorus is X, number of oxygen is 5, oxidation state of oxygen is -2, and overall charge is 0. So phosphorus has the oxidation state +7. Okay, now there is a problem here. In these two examples, H2S2O8 and H3PO5, what we have get is sulfur have the oxidation state +7 and phosphorus have oxidation state +7. What do you think? Is it possible that sulfur and phosphorus having the oxidation state +7? No, it is not possible. So sulfur can maximum have +6 oxidation state and phosphorus can maximum have +5 oxidation state. So the first thing that is come in our mind is that the formula we have studied earlier is wrong. But the formula is absolutely right. There is nothing wrong in the formula, but the only thing is the formula is incomplete. Okay, so to complete the formula, you have to see my next video. So thank you for watching my video.